Okay, lesson 28, the workbook. The following table shows information collected from a survey of high school students regarding whether they have a cell phone and a separate music MP3 player. What value correctly fills in the blank 1? Okay, well, I'm looking at blank 1, and there's two ways I can find it. I can either use the column to find it, or I can use the row to find it right here, because the last cell in this column is our total, and the last cell in here is our total. So I know that blank 1 plus 13 has to equal 70 from, I'm using the wrong color. So let's focus on our our column first, on finding it this way. So I know that the total here is 70, so I know that blank 1, so blank plus 13 has to equal 70. Okay, well, we're going to subtract 13, or in your mind you could think, okay, what plus 13 is going to give us 70? So blank 13 minus 13 is 0. 70 minus 13 is going to be 57. So b plus 0 is b is going to equal 57. And we could check that. Is 57 plus 13 really 70? So this is to check your work. 7 and 3 is 10. 5, 6, 7. Yep, it's 70. So we know that the answer is going to be 57. Now, what if it wasn't that direction? Well, there's another way. We can go the same route but use our rows. We know that in this row we have a blank plus 21 has to equal 78. So then we're going to take 21 from 78. Blank is going to equal 57. And b plus 0 is just b. So either way, we still ended up with 57. So there's two different ways of finding that blank. So great job. Okay, the following table shows information regarding the number of people that participate in different sports at a sports center. How many more women play tennis than men? Okay, we're going to go to our tennis column, and this is men and this is women. So there's 22 women and only 8 men. So what's the difference between that? So what's 22 minus 8? That's gonna leave us with 14. So there's 14 more women than men who play tennis. Let's check that, make sure we're doing our work correctly. Great job. Alright, the following table shows information collected from a survey of high school students regarding whether they have a cell phone and a separate MP3 player. What is the probability that a randomly selected student has a cell phone and no separate MP3 player? Okay, so they want the probability of a cell phone and no MP3. Okay, so they want the intersection, so let's look. We are going to look for the student that has a cell phone. So I'm looking first in this row. So in this row, they have cell phones. And then they want to know no separate MP3. So I'm looking out of these two parts of that row. This one says MP3 player and no MP3 player. So this is the number I want to look at. So 21 students have a cell phone and no MP3 player. Right there. So I'm looking at that intersection, and we have 21 students out of a total of 100. So we're going to type in 21 out of 100. Okay, 21 out of 100. Okay, great job. So again, we used the columns no for the cell phone and where the no MP3 player intersected at. Okay, question 4. The following table shows information collected from a survey of teenagers regarding their weekly reading habits. What is the joint relative frequency of a teenager who reads 1 to 4 hours a week on the internet? Okay, so they want the joint relative frequency. That means just where does the reading for 1 to 4 hours a week on the internet intersect? So if we look 1 to 4 hours a week, we're looking at this row first and then the internet. So they intersect right here at 3. So there's 3 kids right there out of a total of 13. So what is 3 out of 13? That's 0.23, approximately 0.23. Okay, so rounded to the nearest hundredth. Okay, so let's check and make sure our rounding is right. 23 is 100, so we're going to go one more, and that 0 means it stays as a 3, so it's the same. Okay, so then this would be 0.23. Great job. Okay, now one thing that I'm thinking is these two tables represent the same thing. What if I am uncertain as to what do I divide my number by? I would always go to the total and think, okay, well this was a 13 and then it was a 1. So what did they have to divide 13 by in order to reduce it down to a 1? And the answer is 13. You had to divide 13 by 13 to reduce down to 1. So that's another way you can check and make sure you're dividing by the correct number. Okay, the following table shows information collected from a survey of people at a neighborhood meeting regarding how many people have a dog and how many people take walks in the neighborhood. What is the probability that a randomly selected person does not take walks in the neighborhood but has a dog? Okay, so then we're looking for does not take walks in the neighborhood. So there's our column. and they want to have a dog. So that's where these two things intersect. And so there's 21 people that do not take walks but have a dog, and it's out of a total of 100 people. So what's 21 out of 100? And write your answer as a fraction in simplest form. Well, 21 and 100 is already in reduced form. Great job. Okay, question 6. The following tables show information collected from a survey of teenagers regarding how they spend their screen time and whether they wear glasses. Are wear glasses and watches TV independent? Why or why not? Okay, so when we check for independence, let's check what is the probability of glasses times the probability of TV. Does that equal the probability of glasses and TV? So let's find the probability of just glasses. So if we look at that, the wears glasses, and I'm going to use the probability distribution because it's already, the math is already done to put it into a probability format. So if you notice, these are 3 out of 10, and this one is 0.3, and that's 1. So they've already converted these all into probabilities. So the probability that they wear glasses is this whole row. So that whole row has a probability of 0.5. Because that's what its total is. They just want to know how many people wear glasses. Well, 0.5 wear glasses. Now, what is the probability of TV? So then I look at this. Watches TV. The total number of people that watches, or the total probability, is 0.4. So what is 0.4 times 0.5? That's going to equal 0.2. Now, does that equal the intersection? So let's go and find the intersection. So now we want to go to the where's glasses column, and we want to find the intersection that they watch TV. So wears glasses and watches TV is a 0.2. So does 0.2 equal 0.2? Yes, it does. So we have yes, because probability of wearing glasses times the probability that they watch TV is equal to 0.5 times 0.4, which equals 0.2. And 0.2 equals 0.2. Okay, question 7. The following tables show information collected from a survey of students regarding their grade level and how they spend their screen time. Consider the information and use it to answer the question. Okay, what values correctly fill in blank 1, blank 2, and blank 3, and what is the probability that a randomly selected student watches TV given that the student is a 7th grader? Okay, so we're going to find blank 1 first, blank 2, blank 3, and then we'll find the probability that they watch TV given that they are in 7th grade. Okay, so blank 1, we're looking at this first cell with intersection between 7th grader and uses the internet. So we're going to select 6 and out of the total. So 6 divided by 28. And then for blank 2, we're looking at this 8th grader and watches TV. So we come over here, that's 3, and out of our total of 28. So 3 out of 28. And then blank 3, we're here with our total and plays video games. So total and plays video games, 8 out of 28. And someone might ask, well, how do I know I'm dividing by 28 and not by this number 14 here? And I always check the distribution table and I find where there's a 1. So this is a 1, and on here it's 28. So what did you have to divide 28 by in order to reduce it down to a 1? And that would be 28. 28 divided by 28 is 1. So that's how I know I'm dividing by 28. So now let's check our probability of TV given that we are in 7th grade. So that's going to equal the probability of TV and 7th grade divided by the probability of being in 7th grade, or our numbers. So number and number. So the number of people in 7th grade, if I go here, the number of people in 7th grade is going to be this total right here, 15. 7th graders, this whole row represents being in 7th grade. So that's the number of people in 7th grade, so there's 15. And then I want to know the intersection between TV and 7th grade. So I go to watches TV, and being in 7th grade, there's only 3. So that's 3 out of 15. So then we're going to come here to our calculator, and we're going to round to the nearest hundredth. So 6 divided by 28 is going to equal 0.21, and then 3 divided by 28 is going to give us 0.11, because the 7 will round this 0 up. And then we're going to do 8 divided by 28. That's going to equal 0.29, because the 5 will round that 8 up, so 0.29. And then we're going to type in 3 divided by 15, which is going to be 0.2. Okay, and then we're going to come in and enter it in. And we're going to have 0.21, comma, space, 0.11, comma, space, 0.29, comma, space, 0.2. And we're going to check it. Great job. All right, so question 8. The following tables show the information collected from a survey of students. So we'll go again, blank 1, blank 2, blank 3, and then they want the probability that a randomly selected student uses the internet given that the student is in 8th grade. So we have the probability of the internet given that they are in 8th grade. And so we'll go from there. So the probability of internet given 8th grade is going to equal the probability of internet and 8th grade divided by the probability of being in 8th grade, or in the formula it's n for the number and n for our number. So we'll go till there. So blank 1 is 8th graders and uses internet. So I go to the same one, so that's going to be 8. And what am I going to divide it by? Well, I look, there's a 1 right here, and that was 28. So I'm going to divide it by 28. And then blank 2 is right here, and so I'm going to take 14 and divide it by 28. Blank 3 is right here, so in the same cell, we're comparing the same column, same row, same column. So 13 divided by 28. And then the number of people that use the internet, so the number of people that use the internet right here and are in 8th grade, so right here. So there's 8 people that use the internet and are in 8th grade out of how many people are in 8th grade? So 8th graders, there is a total of 13 8th graders. Alright, and we're going to round to 2 decimal places. So we are going to have 8 divided by 28. That's going to equal 0.29 since the 5 rounds that 8 up, so 0.29. Then we're going to have 14 divided by 28. That's going to equal 0.5. And then we're going to have 13 divided by 28. That's going to equal 0.46 because the 4 is less than, this 4 is less than 5, so it stays as 0.46. Then we're going to have 8 divided by 13, which equals 0.62 since that 5 will round it up. So this is going to equal 0.62. Alright, so then we're going to come back to our course player and we're going to type in 0.29 comma space 0.5 comma space 0.46 comma space 0.62. And we're going to submit that for grading. And it says we did it wrong, so try again.
Alright, question 8. We correctly did the work. Everything we did was correct. In the program, they rounded the 0.46 to a 0.47, which is not correctly rounded. So, just so you are aware, question 8, it is rounded to blank 3 was rounded to 0.47 instead of 0.46. Okay. Question 9. An online high school principal runs a report to find that 44% of students are 7th graders who take the bus to school. 12% of students are 7th graders whose parents drop them off. 11% of students are 8th graders who take the bus to school, and 33% of the students are 8th graders whose parents drop them off. The students in the report account for 100% of the students at the school. The results are shown in the table. The principal decides to use the data of conditional probabilities to determine the number of teachers needed to monitor the 7th grade and 8th grade bus stops. A. Find the probability of a 7th grader given they take a bus, and B. Find the probability of an 8th grader given that they take a bus. C. Based on the information from parts A and B, which grade level should have the most teacher supervisors at the bus stop? Okay, so probability that they're in 7th grade given they ride the bus is going to equal the probability that they're in 7th grade and they take the bus divided by the probability that they take a bus. Or we're going to go like this. Probability that they take a bus, 0.55. So 0.55. And the probability that they are in 7th grade and they take a bus. So we go over to the 7th grader column and we go over till it intersects with take a bus, and it's 0.44. So we're going to do 0.44 divided by 0.44 divided by 0.55. That's 0.8. Alright, so there's question A. question B, what's the probability that they are in 8th grade given that they take the bus? That's going to equal the probability of being in 8th grade and taking the bus divided by the probability of the bus, which is going to equal, all right, probability of them taking the bus. We go over to taking the bus column and we go all the way down to the total, 0.55. So there's a 55% chance that the kids take the bus. So then we look at probability of 8th grade and taking the bus. So we're still in the take the bus column. Now we go to the 8th graders and we find that intersection. So it's 0.11. So what is 0.11 divided by 0.55? 0.2. That's going to equal 0.2. Alright, so let's interpret this for question C. 0.8 means 80% of 7th graders take the bus. 0.2 means 20% of 8th graders take the bus. So based off of that, I would say the 7th graders, since their probability is higher, would need more teacher supervision. So we're looking for the probability that 8th graders taking the bus is 0.2, and we're looking for the probability of 7th graders taking the bus being 0.8. And we're looking for 7th graders should have more supervisors at the bus stop than the 8th graders because the probability is higher. Alright, great job. And there's your workbook.